Good afternoon. It's 1 o'clock Central Standard Time here in Seagoville, Texas. We want to welcome you to the Dallas Independent School District STEM Environmental Education Center. We want to say a very special welcome to Foster Middle School from Longview ISD. Teachers, if you're watching and you have not registered, please go to www.tiny.cc/EEC register. Sign up. This is just for our attendance records. Today we're going to do a program called the Sun, Earth, and Moon. During this virtual field trip, students will explore a model that illustrates how the tilted Earth rotates on its axis, causing day and night, and revolves around the Sun, causing changes in seasons. Students will also explore the sequence of events in the lunar cycle and relate the positions of the Moon and Sun to their effect on ocean tides. Ms. Ramirez will tell you about day and night. Mr. Monroe, seasons. Ms. Fuller, the lunar cycle. And Ms. Nash, the tides. You cannot speak to us verbally during this program, but you can go to www.tiny.cc/EEC /question/answer and send any questions dealing with the program that you want to. We'll do our best to answer them. And now I'm going to stop sharing my screen. And Miss Nash, Miss Ramirez, is going to tell you the difference between day and night.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about the cause of day and night. So I'm going to go ahead and share my screen with you guys, and then we'll do a quick demonstration to help you understand that concept. So let me get the screen share started, and we'll go ahead and begin. Let me just pull up our presentation. So I have a couple of quick questions for you. So I want you to think about what are some objects that you guys might see in the daytime sky, and then what are some objects you might see in the nighttime sky, and then think about what are some patterns that you notice as the day progresses. Now, hopefully you guys are thinking of the movement of the sun, maybe the way the shadows change. So think about some of those patterns that you guys might see. And then, of course, we already know what day and night looks like. So during the day, most people think of the sun and the clouds. And during the nighttime, most people think of the stars and the moon. However, a lot of people aren't aware that the moon is also visible during the daytime. And the stars are always there as well. It's just that during the daytime, we don't really see the other stars because the sun is so bright, its brightness is drowning out the light from the other stars. And we also, sometimes we might not be lucky enough to see the moon during the daytime, again, because that sun is so bright. Now, it is important to note that the moon does not actually create its own light. Instead, it's just reflecting light from the sun. So that's also something very important for you guys to know. So that's just some characteristics of day and night. A quick little review. Our essential question for today is what causes day and night, and explain. So hopefully by the end of this segment, you guys will be able to answer that question and be able to explain it by yourselves. So keep that question in mind as we go through the segment today. So we're going to go ahead and get started. We're going to look at what's called the apparent motion of the sun. Now, I'm going to show you guys this little video, make some observations about what you guys are noticing or wondering, and then I'll discuss it with you guys. And as our sun appears to be moving, think about what direction does the sun appear to be rising in? What direction does it appear to be setting in? And is the sun really moving? So hopefully you guys already remember this from elementary school, that the sun is not the one that's moving. It's actually planet Earth. And as you can see in the video, it is Earth that is rotating or spinning around an axis. So I'm going to play that video one more time. Hopefully you guys notice that it appears that our sun will rise in the east. And once it gets to noon, the sun is highest in the sky. And then it appears that the sun will then set in the west. And we know that whole cycle lasts is 24 hours or 1 day long. And then we know, of course, that we call that motion a rotation. So it takes the Earth 1 day or 24 hours to complete one full spin or one rotation. And it's that motion of the Earth that creates the apparent motion of the sun. So that's why we call it apparent, because the sun is not really moving. It just looks that way from our perspective. And again, that is a rotation. So here's a quick little video that you guys can watch on your own time. If you go to YouTube and look up Texas A&M Foucault pendulum, and it's in the Mitchell's Physics building. So if you ever visit the A&M campus, please go visit that physics building and take a look at this pretty cool pendulum. It is over 7 stories tall, and that pendulum bob at the end is over 400 pounds. So it's a huge pendulum. But I want you guys to think about and explain, how does Leon Foucault's pendulum prove that the Earth rotates? So take a look at that video on your own time and see if you can answer that question. So I'm going to stop our screen share, and then I'm going to show you guys a quick little demonstration to help you guys better understand rotation. So here I have a model. Let me just push my computer back a little bit. Here we have a globe of course, the Earth. And then we have a lantern that's going to represent the sun. Now take a moment to think about limitations of this model. So this is a super simplistic model. So what are some limitations or some things that might not be totally accurate with this model? Now the first limitation that I noticed is, of course, my distance is not to scale. And then also obviously my sizes are not to scale. So in reality, we know that the sun is super massive. We know that the sun is much more bigger than planet Earth. In fact, to give you guys a scale comparison, if you were to take a look at your doorway, so if you're at school, take a look at your classroom door, or if you're at home, take a look at your bedroom door. If the sun were the size of that doorway, Earth would only be the size of a dime. So that is to put it into perspective, the size comparison between sun and Earth. But again, this is just a model. So we're going to go ahead and model rotation. And again, rotation is just the spinning of our planet around its axis. And so here we have a stick that represents the axis. It's an imaginary line through which our planet rotates around. And we know that our planet is actually tilted at an angle, and that angle is 23.5 degrees. And we know that it's the Earth's rotation or spinning that causes day and night. So let's take a look at how it works. So I have a dot over here. This orange dot represents where we live in North America. So that's Dallas, Texas for us. I'm going to start our model in this position where Dallas, Texas is right here. So for this starting point in our model, is this representing daytime or nighttime for where we live in Dallas, Texas? So hopefully you guys said daytime. We know that it's daytime because this half of the globe is illuminated by the sunlight. Now, if we take a look at the other side of the globe, hopefully you notice that that side of the globe is dark. So that half of the globe is experiencing their nighttime. Now, also, this point where we are right now represents noon, when the sun is highest in the sky for where we are located. Now, we know that the Earth is going to rotate, and it rotates counterclockwise. So just a review of counterclockwise, if you take a look at a clock, if you imagine the opposite direction of a clock, that would be counterclockwise. Another easy way to remember it is if you just do like a thumbs up, look at the direction that your fingers are moving toward, that is counterclockwise. And you're going to have to do it with your right hand in order for it to work. So your right hand, do a thumbs up, look at the direction that your fingers are going, and that is counterclockwise. So the Earth is rotating counterclockwise around that axis. So we're going to rotate our Earth about 6 hours later. 6 hours later, where we are in Dallas, Texas, is now right here, and that is going to represent sunset. And sunset, we know, occurs in the west. Now, the Earth is going to continue rotating, and we're going to say, I'm going to let it rotate, fast forward another 6 hours. So it's going to rotate. 6 hours later, where we are in Dallas, Texas, is going to end up on this side of the globe. And Dallas, Texas will then be experiencing nighttime, and that will actually represent midnight. Now, the Earth is going to continue rotating, and I'm going to stop it 6 hours later in this spot. And this spot is going to represent sunrise, and we know that the sun rises in the east. The Earth is going to continue rotating, and I'm going to stop at 6 hours later, and we're back to noon. So hopefully you guys noticed I went in 6-hour increments. So we have noon when the sun is highest in the sky. 6 hours later, we have a sunset, and that's in the west. 6 hours later, we have midnight. And then 6 hours later, we have sunrise again, and we're back to noon. So that is rotation, the spinning of the Earth. Now, hopefully you guys noticed in our model, did the sun move? No. So our sun stayed in the same spot. It was just our planet Earth that was spinning that creates the appearance that our sun is rising and setting, but it's actually not moving. Now, it is important to note that our sun is also rotating. So just like our planet is rotating, the sun also rotates as well, but the sun is not moving around. So that is not what is causing day and night. Instead, it is the Earth that is moving, it's rotating, and that is what is creating day and night and the appearance of sunrise and sunset. So I'm going to go ahead and move that away. And so we now know that it takes 24 hours or 1 day for the Earth to complete one rotation. And we know that the Earth rotates counterclockwise. Now, later on in the next segment, you're going to learn another R word, and sometimes students get those words confused. So this segment was rotation, and it causes day and night. And the way that I remember it is rotation has an A just like day. And then in the next segment, you're going to learn the other R word. So try not to get those confused. And then before we go, I have a quick at-home learning project for you guys. See if you can make your own sun and earth model to explain the cause of day and night. So I know you guys probably don't have a globe at home. I know I don't. So see what you have around your house to help you model the causes of day and night. And I'm going to go ahead and pass it to Dr. Gorman, and he's going to answer any questions.
Thank you, Mr. Maris. And the question is, what is the longest and the shortest day of the year? And the longest day of the year is June the 20th, and the shortest day of the year is December the 20th. And they're both called solstices. And now, Mr. Monroe is going to tell us about the seasons.
I don't think you're on, Mr. Monroe.
That type of relationship that the sun, the moon, and our planet Earth has that gives us the seasons. Okay? So, if you'll bear with me, let me share my screen with you, and we will get started. Why do we have seasons? Well, it's because of the motion that our planet, the planet Earth, that relationship in motion that it has with the sun. Now, Ms. Ramirez went over a different type of motion that our planet Earth has, and that is the term rotation. And of course, she related to you that indicates day and night. And in detail, you know, she told you about axis, our axis. The Earth rotates on our axis, and it really takes about 23 hours and 56 minutes. That's equivalent to 1 day, which you guys all relate to it being 24 hours. Now, 1 day on Earth is when one side of our planet faces the sun. 1 night on our Earth is when one side of our planet faces away from the sun. And I wanted to go back over that simply before we get involved in the other motion, which is the motion of revolution. Now, when we talk about revolution, we're talking about moving around an object, okay? It takes the Earth 365.25 days to travel or revolve around our sun once. This motion, this movement, taking that period of time to complete, it is actually called 1 year. And if you look at the image, you can see that it actually is an orbital movement that our planet is actually doing around our sun. Motion terminology. Again, rotation is the spin on our axis. Now in this image, we see that the axis is pointing straight up. But our planet, again, is tilted at an angle of 23.5 degrees, and it stays at that tilt. The other motion terminology is the term revolution, the motion of a body around another body. Or in other words, an orbit. The path that is followed around another body in space is called an orbit. And the path that our planet takes around the sun, guess what? It's not a perfect circle. It is what we call an ellipse. Seasons are caused by how close the Earth is to the sun. In fact, that statement is kind of misunderstood. In fact, the Earth is closest to the sun around January the 3rd. And if you really think about the season, January the 3rd, the season is winter, but we're still closest to the sun. And that's simply because of the type of orbit, the ellipse, that our planet is taking around the sun. And the furthest away from the sun usually happens around July the 4th. And you would think, well, the furthest away from the sun that we are, gosh, it should be cold. But guess what? On July the 4th, that's summer, isn't it? And that's during the hottest time of the year. The seasons are the result of the tilt of the Earth's axis. The Earth's axis, again, is tilted at 23.5 degrees. That tilt does not change. This tilting is why we have seasons like fall, winter, spring, and summer. The number of daylight hours is greater for the hemisphere or half of the Earth that is tilted toward the sun. If we look at these images here during the winter months, and if we're looking at the United States, which is located here, then we realize that the area that's receiving most of the sun's light and heat energy is in this area. So during the winter, we are actually tilted away from the sun's direct light and heat energy. As we orbit or revolve around the sun, the tilt stays the same, but we start becoming a little bit exposed to the direct light and heat energy coming from the sun, and we enter the season that we call spring. Now, when we get into the season of summer, we are tilted toward the sun, and we're getting a lot, in fact, most of the sun's light and heat energy in the northern hemisphere where we're located because of that tilt. And then when summer ends, we start tilting away from the sun, and that season is fall. Summer is warmer than winter in each hemisphere because the sun's rays hit the Earth at a more direct angle during the summer than during the winter. If we were using a flashlight and some object representing the planet Earth, we would see right here that during the summer, there is more direct light and heat energy coming from the sun, saying that the flashlight represents the sun. In the winter months, you would be able to identify that the sun is not directly shining on or giving a lot of light and heat energy. Let me go back. Light energy in this area here. It is more indirect. So basically, it would be winter in this location on our planet. Also, the days are much longer than nights during the summer. During the winter, the sun's rays hit the earth at an extreme angle, and the days are very short. And I know you guys notice that during the winter months, when winter comes in, boy, it gets dark around 5:30, 6 o'clock in the evening. It's dark. And that's because the days are very short. I believe there was a question asked from the last section about what's the shortest day of the year, or what's the longest day of the year. And I'm going to cover that because we are talking about the solstices when we refer to the shortest day and the longest day. Solstices. These solstices occur twice a year when the tilt of the Earth's axis is oriented at its extremes, tilted the furthest or the closest. Winter solstice is the shortest day of the year. In the Northern Hemisphere, it occurs on December the 21st or December the 22nd and marks the beginning of winter. In the summer solstice is the longest day of the year. It occurs on June the 20th or the 21st, and it marks the beginning of summer. Now, the really funny thing about that is that after that summer solstice, each day past that date becomes a little bit shorter as we move closer to winter, the winter solstice, which occurs on December the 21st or the 22nd. And then after the 22nd, guess what starts happening? The days start getting what? A little bit longer. And we can tell now that as we get closer to spring, our daylight, our days are a little bit longer. The other term that I want you all to become familiar with is the equinoxes. The equinox, they actually represent days where there's an equal amount of daylight and an equal amount of night hours. A day lasts 12 hours and a night lasts 12 hours at all latitudes, all locations, okay? Equinox literally means equal night. Sunlight strikes the earth most directly at the equator, which separates the northern hemisphere from the southern hemisphere. This occurs twice a year. The vernal equinox, which actually is referred to as the spring equinox, occurs March the 20th. And at this point, I'm going to offer a challenge to you guys. And you guys probably won't remember this, but on March the 20th, what I would like for you students to do is to observe and check it out. See if there's an equal number of daylight hours as compared to nighttime hours. That might be pretty hard for you all to do or to remember to do, simply because you students are probably pretty active, okay? Now, that's the spring equinox, and we're coming up on March the 20th, so that's not very far away, is it? Now, the autumn or fall equinox occurs September the 22nd or the 23rd, and of course, that's next fall. So I know you're not going to remember to kind of observe that. But if you get a chance, I'm going to issue that challenge. Check out March the 20th and see how accurate the spring or the vernal equinox is. The Earth's seasons are not caused by the differences in the distance from the sun throughout the year. It's actually caused by the tilt of the planet Earth on its axis. Now, I'm going to give you something else to think about, and then I'll be through. But You remember when we were talking about how long it takes the planet Earth to orbit around the sun? 365 days, 0.25. Well, that 0.25 is equivalent to 1/4 of a day. Every 4 years, we have an extra day that is added to the month of February. That particular year is called a leap year. And this started a long time ago. It started with a Roman emperor by the name of Julius Caesar, who really, with the people around him, realized there was an excess of time at the end of each year. And then later on, there was a pope by the name of Pope Gregory the 13th, who created a calendar called the Gregorian Calendar. And every 4 years, guess what? It was called a leap year, and there was an extra day added to the month of February. And I want you guys to do a little research and find out when we're going to have another leap year. That means an extra day added to the month of February. I want you guys to have a good day. I'm going to stop sharing my screen, and we'll look at this model just for a second. In this model, you see that the planet Earth is on its tilt. On this side, we have the United States, the continental United States. And because of where it's located now, I would say that it's not getting a lot of the sun's direct light and heat energy in this model. And I would dare say that it's probably in the month of, or in the season of spring. Now, as I rotate this around, we notice that the United States, the continental United States, is facing away from the sun. So I would say that probably we have actually moved into winter. And then we're coming back around, and here we are again. It's close. So I would say this is probably spring. And then we're getting a lot of the direct sunlight from the sun and heat energy. That's summer. And then the whole season to season pattern starts all over again. Hopefully I've been able to help you understand why we have seasons. I'm going to turn it back over to Dr. Gorman. And if any of you have any questions, he can answer them for you.
Thank you, Mr. Monroe. Yes, we did have a question, and it's also a question I want you to ask yourself. I want you to ask yourself, what is your favorite season and why? Okay, now there were several polls. One of them was the Gallup Poll, and that's a very well-known poll where they go around the country and ask people the question and get the answer, and they compile the information. Okay, if you lived in the northern states, say in Maine, Montana, North Dakota, something like that, those people have a tendency to say that spring is their favorite season. They're tired of all that old cold, icy weather that they've been having. And what we had a couple of weeks ago for 1 week, they'll experience up there for 2 or 3 months sometimes. So their favorite season is spring. Oh, here comes the sun. We're tired of winter. However, down here around Dallas, Texas, people have a tendency to say they want the fall because they've had all that hot summer. And you know, August and part of September really gets hot in this area. Now we're going to let Miss Fuller tell us about the lunar cycle.
Hello, boys and girls. We're going to be talking about the moon and the lunar cycle. So let me share my screen with you. Phases of the moon. Now here's a quote from the play Romeo and Juliet by William Shakespeare. Oh, swear not by the moon, the inconstant moon, who monthly changes in her circled orb, lest that thy love likewise variable. So what's Juliet saying to Romeo? She's saying, every time you look in the sky, every night, the moon is different from what you saw the night before. It changes constantly, and I don't want your love to change. So Juliet, she was 13 years old in the play. She recognized the phases of the moon. So what do you see when you look in the moon? A lot of people call it the man in the moon. They see a grumpy face. And some people in different cultures around the world see different things. Some see a dragon, a dog, a woman, a buffalo, a rabbit. Someone pointed out to me the rabbit, so I'm going to show it to you. There's the oval face of the rabbit, the long rabbit ears, the two front legs of the rabbit, the fat rabbit body, the long back legs of the rabbit's jumping over the moon, and following is the big fluffy tail. And once I saw this, I don't see anything else when I look at the moon, but you may see something else when you look at the face of the moon. So, does the moon rotate? Now, a lot of kids ask me that. Does the moon rotate? Well, we only see one side of the moon. And the reason why is the moon rotates and revolves at the same speed. So the moon spins once a month, every 29 and a half days, as it circles the earth. That's why we only see one side of the moon. This is called a synchronous rotation. It's tidally locked as it revolves around the earth. Now, like Ms. Ramirez pointed out to you, the earth is tilted on its axis at 23.5 degrees. And Mr. Monroe pointed out it's that tilt on the axis that causes the seasons. Well, the moon is also tilted on its axis, but it's very small. It's only about 5 degrees. So we have some different pictures of the moon down here. The moon does not have its own light. It simply reflects the light of the sun. So we see these different phases. The first phase is called new moon. It's this dark spot right here, and that's what we're moving toward right now. Right now we're in what's called a waning. This is the phase we're in, a waning crescent. And the new moon is the first step or the first phase of the phases of the moon. When the dark side or the dark shadow is on the right-hand side of what you see, that means it's waxing, growing larger. So then we have a waxing crescent, then we have a first quarter, waxing gibbous, and then the full moon. Everybody's always excited to see the full moon. Then we go to waning. Waning means growing smaller. Waning gibbous, three-quarter moon, waning crescent, which is where we are right now, and pretty soon it'll be the new moon. Now, I'm going to show you a brief little, and it really is brief, video from NASA. And it's going to show this line moving across the face of the moon. This line has a name. It's called a terminator, just like Arnold Schwarzenegger in the movie Terminator. Well, that's the terminator right there. So watch this. Right now, we see the dark side is over here on the left. So this is going to be a waxing gibbous that you got right in front of you. And in just 1 or 2 seconds, it's going to be a full moon. So watch this. Okay, there we go. Full moon. Now it's waning gibbous, first quarter, and new moon. Here we go. Waxing, first quarter, full moon, waning, and there you go. So I'm going to go ahead and stop it there, maybe. Having trouble in paradise. Okay. All right, I'm going to go back to present. And that didn't work out well for me, did it? So let's exit and see if we can go to a different slide. Here we go. Now let's talk about the new moon. The new moon appears to be totally dark. It rises and sets with the sun, and it crosses the ecliptic. That's that big line in the sky that the sun and the moon and the planets follow as they rise in the east or appear to rise in the east and set in the west. It represents the first stage of the lunar cycle. Now, what does the word gibbous mean? The word gibbous comes from a word meaning humpback, and the gibbous moon is one that appears to be less than a circle, but more than a semicircle. And our moon has a waxing gibbous and a waning gibbous. So on the left is a waxing gibbous. The illuminated part is growing larger. And on the right, we have a waning gibbous, which means that the illuminated part is growing smaller. Then what is a crescent moon, which is what we have now? A waxing crescent moon can be seen in the western sky a day or so after a new moon, and it slips below the horizon with the setting sun. Waxing means growing. A waning crescent moon can be seen in the eastern sky before dawn. Waning means getting smaller. This used to be called an old moon. And then we got first quarter and third quarter. Now, the first quarter moon occurs approximately 7 days after the new moon. It represents the first quarter of the moon phase cycle. It doesn't mean a quarter of the moon is illuminated. It means that the quarter of the cycle, the first quarter of the cycle. And it's a waxing moon and half of its face is illuminated. The third quarter moon occurs approximately 7 days before the new moon and represents the third quarter of the cycle, and it's waning. The other half of the face is illuminated. Now, we've been talking about women in science this week. So this is Mary Jackson. She's an aerospace engineer, well, was, she's not now, but she was an aerospace engineer at NASA, and she worked on the Apollo 11 space launch to the moon. And very often the kids will ask me, what's the name of the moon? The name of our moon is Luna. And I'd like to challenge you to observe the moon every night for 2 months. Record your observations in your science notebook every day. What did you see? All right, now I'm gonna show you something else. So let me escape from this. And I wanna show you, if your grandparents or your parents take the Dallas Morning News, there's a section called Metro and Business. On the back is the weather page, but at the bottom half on the right-hand side is something called Sky Watch. It's going to tell you what phase of the moon we're closest to and when each of the big phases are going to be present. So we're going to have a new moon on March the 13th. Well, that means the moon is waning. Well, tonight, actually it'll be tomorrow morning, an hour before sunrise, we're going to have a conjunction, and that's where you can see 3 planets and the crescent moon all at the same time. So remember, an hour before sunrise. So that's going to, an hour before 6:45, that's going to be about 5:45, maybe 5:40. I would be out there at 5:40 to see this. But you're going to see a waning crescent. You're going to see Jupiter. You're going to see Saturn, and you're going to see Mercury, and it's going to be wonderful. And I hope you have a good afternoon. And now, if you have any questions about phases of the moon, Dr. Gorman would be more than happy to answer them. Thank you.
Thank you very much, Ms. Fuller. And the question is, what is the size of the moon? The diameter of the moon is 1,079 miles. Now, just to give you something to compare with, the diameter of the Earth is 3,958.8 miles, right at 4,000 miles. So the Earth is about 4 times bigger than the moon. And now, Miss Nash is going to talk all about tides.
Hello, welcome to my classroom. And today we're talking about tides. And tides are the movement of the water on the planet. And of course, if we look at our planet, you can look at that Pacific Ocean that's covering most of our planet. we should be calling it planet ocean because most of it is that one gigantic ocean. And water, as we all know from our bathtub time, can slosh. Okay? And so the tides are the kind of the sloshing of the ocean water around the planet. What causes that? Let's see. We're far from the ocean, so we don't usually have had a lot of direct experience of this, but we can look at some pictures, and next time you go, if you can go to the coast, you can kind of experience this and maybe you'll understand what's going on. If people there say, oh, tomorrow's the high tide or the low tide, you'll know what they're talking about. And tides, what are they? What are they caused by? And are they different kinds? So tides are caused by the gravitational pull of the sun and the moon. Mostly the moon, but the sun is also involved because, of course, the sun has gravity, a lot of gravity that holds the planets in orbit. The Earth has gravity that holds the moon in orbit around it, but the moon, because it's so close to the Earth, also exerts a lot of gravitational pull on the Earth. And the water, which is kind of loose on the planet, is more affected than the dirt, than us, right? So here we can see that the sun and the moon are both acting at the same time on the Earth. So high tides are caused when the sun and the moon are in a line, okay? And on the way. So if they're lined up like this, okay, then this is a low tide. When they're lined up like this is high tide. They're pulling more strongly on the Earth. Now, so every 24 hours, there are 2 high tides and 2 low tides, okay? So both of these things vary in their intensity, depending on where they are. So the highest tides on the planet occur in the Bay of Fundy in New Brunswick, Canada. The tidal range or difference between high and low tides there can be 16 meters or 52 feet. You can see the low tide up here on the top. These boats are sitting in the mud, okay? And look how high up the dock is. And then at high tide, the boats are floating nicely up. So these extreme high tides in the Bay of Fundy are caused mainly by the shape of the bay itself. Okay? So it causes it extremely high. And people go down there as tourists to walk around where when the water goes out. You have to be careful to get back up higher when the tide comes back in. So these things called tidal islands, okay, can offer protection. So this one is in England, okay, and it's an island that at high tide has water all around it, and at low tide people can walk on out. They have a little road here, but it's covered right now because it's high tide. And in France, there's another island that, again, it's surrounded by water at high tide, but accessible at low tide. And then you can also find all kinds of interesting things like these fossils in New Zealand at low tide. So climate change is affecting tides and tidal flooding in coastal areas. As ocean temperatures increase, the warmer water of the ocean takes up more space. And at the same time, melting glaciers and rainfall are putting more water into the ocean. So this contributes to sea level rise, contributes to higher tides, and it combines to flood coastal areas. And also extreme weather events like hurricanes also add to this severity of flooding. Okay. So here's some places that experience frequent and catastrophic flooding. Bangladesh, the whole country is almost at sea level, so they're in big trouble. And Miami, of course, is also very low and subject to lots of flooding on a regular basis. And famously, Venice, okay, which is also sinking at the same time. But they also, here are the tourists. you go, you think you're gonna be a tourist and you end up having to wade through knee-high water, okay. So one good thing we could do with tidal energy would be to produce electricity. Okay, so we could use that tidal energy to in and out like we use wind, okay, blowing around. And the places with the highest tidal energy, so here's North America, up here with Alaska and Canada. This has a lot of tidal energy. Up here, here's the Bay of Fundy right up here. Okay. So they have lots of tidal energy there too. So those are places where you can use it to spin big turbines or all these kind of interesting contraptions they're trying to figure out to use that energy to produce electricity. In ancient times, they also used it to make a water mill. So this is like you use a river or a dammed up pond to turn a wheel and turn a mill. They used the tide to do it. And here's one from New England. Okay, this is one that's in France, I think. But people also use that tide as a way to trap fish. So the fish would come in with the water on high tide. They had the trap set up, and then when the tide went out, the fish were trapped. These are called fishing weirs, and these were used all over the world by people on the coastal areas. And in some places, that's a scary thing, if the tide goes out and the sea ice is frozen on top, you can go down under the ice as the tide goes out and gather mussels, okay, under the ice. But again, you got to be careful to get out of there quick. Tidal pools that form when the water goes out are also a great place to go tide pooling and look at all the amazing animals that live in that little habitat. So tides are an interesting thing to experience. You're not too far from the Gulf of Mexico. You can go down and experience it for yourself. So I'm going to turn it back over to Dr. Gorman for any questions. Thank you and bye.
Thank you, Ms. Nash. And the question is, have you ever had any personal experience with tides? And I've had a lot of it. I spent 4 years of my life in the Navy. About 2.5 years of that was floating around these huge oceans on these great big aircraft carriers. And in Japan, there were 2 ports, I think Sasebo and Yokohama, that we could not go take those big old ships into the ports unless it was high tide. We would get stuck on the bottom, and those things are so huge, you did not want to get them stuck. So the harbor pilot would come out, we'd go pick him up in a helicopter, he'd come out and he'd tell us the exact time that we could take those big old aircraft carriers and get into the port. Now, once we got in the port, they had cleared it out enough to where with no problem there. But getting in and out, we did have to go in at high tide. And now I'm going to share my screen. During this virtual field trip, students explored a model that illustrates how the tilted Earth rotates on its axis, causing day and night, and revolves around the sun, causing changes in the seasons. Students also explored the sequence of events in the lunar cycle and relate the positions of the moon and sun to their effect on ocean tides. Mr. Maris covered day and night. Mr. Monroe covered the seasons. Ms. Fuller talked to you about lunar cycle. And Ms. Nash covered the tides. Thank you. Teachers, how did we do? If you would go to www.tiny.cc/EEC feedback and fill out a short form, we would certainly appreciate it. That's the end of the program for today. We want to thank you, students and teachers, and we want to encourage you to have a great day. But most importantly, students and teachers, I want you to have a great life. Thank you. Come back and see us next time.